Hello. Hey, Monica.
Hey,
Good
Gash.
morning. Good morning. Good
Good
morning.
morning.
Sorry, just getting started. This is a bit early for my thing, but let's do it.
No worries. I appreciate you making the time.
No, thank you. I think I was doing some groundwork. We can relatively set this up quickly, hopefully in the hour, and then launch the jobs and kind of hopefully the weekend. You know,
Hmm.
um, why don't I? Well, I'll start sharing screen. I still need to log in, but you can watch all of that. So hold on.
Yeah.
I need to do a bunch of logins first. Uh, right, that's, and then uh, uh, this is the Wiseman. Okay. Um, what I will do is temporarily create. I'm recording this and I will push the code, so don't worry about any of that.
Oh, perfect.
You will have all of access. Push the GitHub and all the good stuff. So don't worry.
Great. Also, I just realized I forgot to send you the paths to some
No,
of
we
the
could do it
different
together.
files. So my apologies,
No,
but I can
no,
share those.
don't worry. Yeah, we could do it together. Like that's fine. Okay, let me know if is it reasonably visible on your end, like the zoom
Yes,
factor?
it's perfect.
Mhm. Biological plausibility analysis. It's good to give names sometimes.
Mhm.
BPA. Okay. Oh, all right. Okay. So all right. So first, what is? I actually have a cool thing. I think. Let me see if I can. Oh, sorry. I'm setting things up a little bit, if you don't mind. Uh,
You're good.
extensions? No, not extensions. Sorry. What the heck? Okay. Anyway, I'll copy paste. Usually, I have a thing where, sorry, if you don't indulge. Oh yeah, this is the icon I was looking for. So I think this is something you could. Well, hopefully, if it works. Let's see if this works. We have to do it from Carlo. I don't know if that will work from Carlo, but let's see from. So you can actually do SSH from Visual Studio. Um, and then you can actually like run commands directly from within Visual Studio instead of copy pasting
Mm.
into a terminal. I will try to
I
demonstrate that.
don't use, I've never, you said Visual Studio. Is this a
Visual
specific
Studio Code,
application?
Visual Studio Code. Yeah, it's like this is a text
Oh,
editor, basically. Yeah,
okay.
this is a Visual Studio Code. I love
Mm.
this Visual Studio Code. It helps, like it supports lots of different languages, and it's like coders,
Yeah.
like programmers' favorite, like one of the favorites.
Oh, cool. I'm more familiar with Atom, but I haven't tried
No, Visual Studio Code is
this
bigger
one, Visual
ecosystem.
Studio.
Yeah.
Oh,
Hmm.
okay. Good to know.
Yeah. Okay. So first, I'll show you what I mean by this. So if I say, then it's like a notebook. You can build like a notebook. This is the thing I keep talking about is,
Hmm.
a lot of times what happens is you write scripts and you copy paste and run them, but what's missing is what sequence you ran them. Yeah, you can share a collection of scripts and stuff. What exactly was done would be missing from that piece. You can share the code, but what's missing is what exactly was run, what sequence. And a notebook actually shows like literally what you're doing, like
Hmm.
that's a kind of a nice provenance that you can, for your own sake, let alone others, I mean, uh to go back and look at other, what you have done. I'm constantly switching between projects, and this was like a necessity is the mother of invention type thing. I mean, I didn't invent anything, but I just landed on this kind of framework where, okay, I'm switching between Brittany's project, Janet's project, Stacy's project, and then it helps to pick up where I left off relatively easily without actually having to. Yeah, that's why. So you see what happened? I just hit Shift Enter, and it
Yeah.
actually ran here. So then I know, like, I'm actually, I can keep track of what I'm doing. You see what I'm saying? Like, so okay, it's like a notebook. Basically, you're writing in your notebook. Okay, so where is the path? Tell me. Let's first orient
To
myself.
okay, I'll show you like the sort of parent folder where everything is.
You want to show or you want to
I can put it on the chat or whatever
chat?
is
That
easiest.
way
Yeah.
I can, if it'll show up.
Okay.
Perfect.
And then
So which so these would be okay, nodes, masks, and okay, let me try to guess.
I can also point you to, there are a few files like the FODMAT, for example, that is actually separate that I can also point the path to that. But in these directories pretty much have like all the nodes, all the connectomes, tractograms, CIF files, like more so the outputs of the actual tractography steps.
So basically, you want the angle 4, I'm guessing, like, so angle and whatever. Those tag files, these are the ones. No, I want the whole brain tags, right?
Yeah,
Whole
whole
brain.
brain track. So go, okay, so on
Well, let me share control. I don't know if it'll work for you. You could, I don't know if I can give you control also.
I put the
Oh, you put the whole brain. Yeah. This is the one that you use for tag to connectome, right?
yes.
Got it. Oh, okay.
Because we have like a separate
Oh,
like a
okay.
separate folder for like the whole brain and then a separate folder for like individual tracks that we've extracted. So yeah.
So this would be, so each of them will have the, oh, this is just the, so which, why do they all have different namings? So can you tell me what these
Yeah.
two are?
So the first one is just like the sample, the 20,000 streamline smaller file sample. And the one that doesn't say 20K sample, that's like the full 100 million streamline tractogram. The
Okay,
other
but
detail
what?
I was gonna, yeah,
Yeah,
sorry, what?
go ahead. What's ABMD?
AB is Allison if she ran it, and
I see.
MD is
I see. I
my
see. Okay.
my
Okay. Okay. Yeah. Gotcha. Okay, so the one we really want are the AB and MDs, basically.
yes. But then the
Okay.
other thing that we can actually do that really quick is the directory for angle sorry, angle 30 is actually at a different
Oh.
directory because we generated that tractogram when we were testing seeding. So like it
Can
was
you?
generated earlier at a different
That's fine.
so I'll point
So
out
hold
where
on. Yeah.
that is. Yeah.
Paste the chat. Yeah. Mm-hmm. Okay, we got this. And then where is the 31? You're pasting it, I'm assuming. Okay.
Yeah.
Yeah. Okay, this will give us how many? Let's see how many there are. 5. Yeah, 5 full brain tracks. That's perfect. Now what we need are the assignments.
Yeah.
Text. So where are those?
I'll point it out.
I'll start saving this.
Mhm. Okay, once again, the angle 30 is
That's fine.
separate, so
Short
I'll put
lived.
it here. And then
Not really a CSV, but okay. I think it is not, or maybe it is. Yes. Okay.
okay.
You could imagine it CSV. This is the assignments. Okay, good. And then one more, 4 more, right? Yeah.
Yeah.
Let me make some comments. So
Is it okay if I put them separate? It's just each of these folders have different
fine.
iterations of things that have been run. We need to clean these
Yeah, that's fine. Totally fine.
directories a bit, but for the sake of clarity, I'll just put them separate.
Mhm.
Mhm. Okay. There are the others.
Mhm.
And the 30 is in the message above.
Yeah,
Mhm.
I already got that. Yeah. Oh, I think we need to get the that's okay. So how are we starting? So we want the 15 is the first.
Yes, true, because
15
we
is the
don't want to
first.
do the 4 really.
No, we could do it. I mean, I don't know. We'll see what
Okay.
happens. I mean, why not? So we're doing 4, 15,
30,
30.
44,
Yeah.
35, and 90.
Now I'm ordering them so that we can match the tag files.
Mm-hmm.
So yeah, 4, 15, 30, and 45 and 90. Okay, that's good. Let's see the order for the tag files. Although this will probably, oh, so this is the 31 you said. Okay, so I think I know how to do this. 4, 15, 30 is separate. So let's do 415 first. And then 30 is the other one. And this is a 30. And then you have 45 and 90, right?
Mm-hmm. Yeah.
Perfect. Now these are ordered. I think. Okay, good. So this is assignments. That's good. I think this is all we need. I was looking at the connectome. I haven't used connectome to so connectome. Well, this time let's use the terminal to make sure. Let's actually be in Aldi. So that's where let's try to submit the Condor jobs. I think that's the best option we have. Local Condor, I mean, yeah. But will all of
One
them, yeah,
quick
go ahead.
question I have, and I would love to get your thoughts, like as you look through the connectome to TCK documentation. In the
Mhm,
past, there's an option that is TCK underscore weights underscore in,
mhm.
and you have the option of inputting the SIF to
Yeah.
weights text file. We've been including that. I don't quite understand how, if connectome to TCK is really doing anything with that information for the like extraction and visualization of the tracks. Like, I don't know how it takes into account the sift weights in that step. I just
Hmm.
know the option is there and we've been including it, but I don't know, yeah,
Yeah,
how
let's do
that
that.
plays out and if we.
No, no, it is good because basically you can do a hand calculation, sort of by hand verify that for, let's say you take node 1, node 2,
Mhm.
you extract node 1, node 2, you feed in the tack weights, and then you have an output file. Literally, the edge weight that you get from FBC will be the sum of all the weights that you get from this. Yeah, can you pass the files for tack weights
Yeah,
also?
I'm
Yeah, let's do that.
looking for
Mm-hmm.
them.
No worries. Let me take care of a few chat messages if you don't mind.
Yeah, no worries.
Takes care of that.
Okay, 4, 15, 30, 45, and 90. All right. Next. Yeah. Okay, those are the SIFT files.
You call them SIFT. Okay. They're the weights.
Yeah, the weights.
Not the connectomes.
No.
Not the connectomes. Okay, good.
Oh, sorry. Yes,
That's okay.
that was already in my.
That's
No,
okay.
that is SIFT, not connectomes.
Yeah. Clicker. Oh, we are on a different computer. Sorry. What the heck? Okay. You notice you're getting more streamlined as we proceed in the notebook. That's the pattern you'll see.
Mm.
Oh, there's a connectome. Oh yeah, that's okay. That's because I typed something before. Okay. Uh, now all we need to do is pick a nice one. So this actually is the one you probably tried before when you said you did the whole batch, right? This would do all pairs basically. For every edge in the connectome, right? But basically but this will run sequentially is your point, or this is not fast enough is your point, right?
Yeah, sequentially, I was thinking through this, and I had another potential approach. I don't know, it might be rudimentary or not that great, but the way I was setting it up was I first created a text file that has essentially a list of all the pairwise combinations and their corresponding node number. And then I was setting up my code so that I input that into the submit file, and the submit file itself takes all these combinations and inputs it into the script, but then assigning each individual one as a job that will run in parallel. And by doing that, the way I was running connectome to TCK was just there's an option where you can do, I think, use the exclusive, over there, the exclusive option, and just select, 2 select nodes. And so by doing it like that, and with the setup that I have through my submit file, it'll just run this code for every single pair in parallel, at least theoretically.
Yeah, that's what we'll do then. That's what we'll set up basically. I'll show you how to, and then that's the most important. Then we'll have to add the tech weights and those things, right? Basically, and yeah, I'm just looking at. Okay, so let's pick this. Yeah, let's do that. What is file single mean? What does the files option do? Oh, it just gives you one file. Is that right? Or let's see what the files. Select how the resulting streamline will be grouped into. Oh, per edge or per node or per single. Okay, so single would be basically one tag file, basically. Okay.
Yeah, I mean, I usually don't include that option.
It's
I don't
probably by
have that
default.
file option, and yeah, by default, it just gives me one file for that one edge.
Yeah, this is the file. Like, yeah. Let's set up some basic pseudo, So our combinations, this is the combinations we want. Uh, uh, and we are sure there are only like num nodes is 68, right?
68. Yeah.
And number of angles is 5.
Yeah, 5. Yeah.
So the total combinations is, that's I listed in the email, 67 divided by 2 times 5. Oops. Right, that would be, which would be what? Let's try that. 68, so 34 times 67 times 5. Correct? My math is correct, right? Yeah.
Yeah. Why,
11,000.
sorry, this might be a very silly question, but why is it times 67 and not
Oh,
68 by 68?
yeah. Basically, this will not include the diagonal. That's the 68 I'm subtracting
Oh,
here. Yeah. We don't need the self
oh, yeah, yeah,
connection.
yeah. Of course. That
Yeah.
is okay. I had not thought about that, but yeah, duh.
No worries, no worries, no worries. No,
Uh,
I've done this.
okay.
It's not on the fly calculation, on the fly explanation. There's a difference between on the fly explanation and on the fly calculation. You know that, right? Like, so, yeah, don't worry about that. So, okay, so this is the number of things we want. Let's start doing it. First, let's set up the core command.
Mhm.
So this will depend on the angle, right?
Yeah.
No, weights. Let's actually set up the weights structure too. Let's set up the weights so that we need to get the, okay, attack weights. And so there will be two outputs. One is the, got it. So first let's get the attack weights in. I think the order doesn't matter. I don't know. I think it's smart enough. You think you're calling them SIFT, but okay, SIFT. And prefix track weights out. Let me just track weight. Okay. This is what we want. This is what we want to
Mhm.
condorize, Monica. What do we do?
Mhm.
Okay. We want all the combinations. I'll show you some magic. I mean, in the sense like parallel is the good one. Set it up. I'm just thinking, okay, first let's get the inputs, I guess. So first input, let's call it, uh, let's call the first input as what? Tracks. And you know what? For readability, I don't like giving variable names, but let's give variable names. I don't
Mm.
I don't like to do that, but I think for readability and for pedagogical purposes, I think let's do that. So let's get all of these. Let's give names to all of these.
Yeah.
Um, uh, let's call it I don't know, tracks angle 4 equals that. Only gonna pick 4. That's for that. Oh, do we know A, B, M, D, which one is which? Can you say for
Mm.
4 what it is? Like, is it A, B, or M, D?
For 4 is MD. Hold up. Let me double check.
It's okay. Actually, can you paste the, now that I'm thinking, can you paste the, uh, oh, actually, yeah. Can you paste the actual paths for all of these? Or just tell me. I don't know. That
The
way I wanna name them like this, I think. Usually
like
what I would,
the
go
path for
ahead.
each one individually?
Yeah, yeah, like you did for the
Yeah.
assignments. That way we have like, I'm not like doing these edits like, yeah. Well, in the
Yeah.
meantime, I'll set up the other things, the assignments and the um weights.
Okay. Yes. Let me.
And another thing I typically do is have a split window. So I can scroll up and down. So I don't need to scroll up and down when I'm editing. I can, for example, I want to refer to the previous parts of the notebook. I can just go back here without actually going. You see what I mean? This is another trick.
Yeah.
So I don't need to go up and down and like copy. And then I have a notebook. The same notebook can be looked in twice. Like, you understand what I'm saying?
Yeah. Yeah, it's smart.
These are all tricks I developed over the years.
Right. Oh, the tractogram names
Yeah.
are there.
Sheets are done. Now you have the tracks. I have too many teams open. Well, I think it was in the in this. I think, yeah. The weights are named, assignments are named, naming the tracks now. Okay. Oh, did I overwrite? There is my tractograph name not showing up. Do you see what I mean? That's weird, isn't it? Well, it's okay.
Oh,
That's
like,
okay. Don't
yeah,
worry.
the
Yeah, that's okay. I think I can try to paste it like this. I was trying to overwrite the. Oh, did I? I think I copied twice. Okay. I must have. Oh, there. Okay, that's fine. That's fine. That's fine. So also verify whether I'm doing things correctly. So this one, why is this just the path? We don't need that, right? Don't think we need this.
yeah.
What? Did you not? So this one also we don't need. I don't know why we don't have the 4. I'm not sure if I copied. What happened? Why is there twice 30? What did I copy? I think I copied. Something happened. I don't know what. You see what? That was weird.
Yeah, that was.
Why is it says volumes? Okay, I don't know. That's okay. We'll
Oh,
fix
that's
it.
just the way. Yeah, on Macs, the way
Mm-hmm.
the drive is. Like if
Access.
I copy directly from my like Finder, it
Mm-hmm.
just instead of study 3, it just says volumes.
I see.
Just the way
Okay,
it's loaded in or whatever.
let's try one more time. Oh, I think I overcopied because there's this connectome files too that I had copied. That's why. Some weird stuff. Oh, maybe this is the one. Okay, I just need to delete this part. Okay, I think I extra copied actually last time. That's what happened. Okay. So verify as I'm doing it, yeah? Like just an extra pair
Yeah.
aside, just to make sure, which is why we are doing it together, which otherwise I'm gonna to suck up a lot of time. This is why two is better than 1. Oh, this one needs to be studied.
Yeah, studied.
Okay. All right, everything is named. Oh, I should have done one more. Sorry, I just realized there's a better way to do this, which I will do in a second. Totally. We could make an array of this. So, yeah. You just put like this. But we need to make sure the order is the same.
Okay.
I think you just have a space. Less fewer names. You see, you don't have all the, but we need to, of
Oh,
course,
I see.
make sure the order is matching between the arrays, like tracked array, assignment array, and the weights array. The 4, it needs to have the positional matching, like 1-to-1.
Yeah.
Yeah. As you do it. So, okay, so this one is first array. So let's actually verify this array construction. I believe this is how you do it, but let's double check. Now, if I say echo, the way you access the array is all of them. Okay, good. If you want the first one, angle 4, and like if you say the fourth one, which is angle 90, perfect. You see what I mean?
Yep.
You got the
Okay.
tracks array, then assignments also. Let's do the same. To keep adjusting, I have ergonomical. $45 and 90. And then weights. Okay. Let's set up the basic skeleton. So this is something I would recommend. I don't know if you, yeah, like just Google like for GNU Parallel, and there will be tutorials on this. Let's first just do a basic thing. I mean, we'll have to do a bunch of things, but parallel, beautiful. And first one would be attract. I don't know. We can call them. Let's say there is header. We'll give header to the variable names. I'll show you. It might seem like too much, but you'll love it as soon as you start doing it. Assignments. This one, yeah, this one would be what you might call it. What's the best way? Node 1, node 2, I guess. I don't know. I'll try. Sometimes I'll do trial, but the only thing is node 1, node 2. Oh, actually, I know. Yeah. I mean, I guess we can call it from to or to from. I guess, does it distinguish between, so if you put 1, 2 versus 2, 1, you'll get the same, right?
Yes, and then so for the output, MRTrix just asks you to put in, a prefix. So I usually put in the region names, and then it automatically, for every output, it automatically adds the number of the nodes with the smallest number first, and then .tck.
Oh,
Does
is
that
there
make
an
sense?
option? Like here, is there an option here?
So
Oh,
yeah,
nodes list.
let's
No.
no. Like if you go to the example that they give where they use
This one? Which example?
yeah.
These are the...
Like if you look at the very basic in the usage, the very basic
Oh, I see.
at the very top, like it just says you just assign the prefix, and then let me see where it says where is it? There might be different ways of naming it. I guess the way I've been doing it, but it has just been just specifying the
No numbers?
actually we don't even have to put in, sorry, I'm like thinking through, I guess we don't really have to put in a name or anything, because it'll automatically extract, like it will automatically add as it creates the track file, it'll automatically add the node number. So that's that is enough of an identifier
I see.
for us to
I
know
gotcha.
what it is, if that makes sense. So I don't think we need
Yeah.
to
I don't think we need to
specify.
add. Well, but why do they say it like this here? Extract only. Then why do they add it here?
Yeah, I don't know.
We can add it. It's fine.
Like I can.
I think that's okay, right? This should be. No, all I was asking more about the logic that 1, 2 and 2, 1. If I change it to 1, 2 or 2, 1, it should give me the same answer.
Yeah,
Shouldn't
I
it?
think so. Yeah.
So let's just name it node 1, node 2, because from 2 doesn't matter. Oh,
Yeah.
these are asymmetric. I mean, undirected graphs. Yeah.
Mm-hmm.
Okay. And then this would be the, let's call it weights. I don't know. Yeah, weights. Tracks. I mean, let's call it tracks, assignments, weights. Let's give those in order, actually. And then we also want to output the weights for the node 1. Literally, if you sum these weights, you'll get the connectomes. There will be a kind of good hand calculation check. Not hand, I mean, but like so. Okay, so first, let's give the weights. That way we have a nice reading. So you have tracks, assignments. Oh, no, the option should be at the end, I think, or at the beginning. So all the options need to be, so this order needs to match. So tracks, assignments, and output. That's what I think they want. Tracks, assignments, output, and then whatever the options. You can have nodes, you can have exclusive, file, single. All right, so far so good, So far, I don't think we need this reference node part right now. So let's use more screen space. Let's call them. Now let's invoke this. So this is the first parameter. And we want to have one-to-one mapping to assignments. We call those assignments and assignments. So that's assignments, and the one-to-one mapping, that's plus. That's what the one-to-one mapping would be to weights. I'm giving a name. What did I call them? Weights. Yeah. So this naming, so this refers to this. I'm giving the name for that list, basically. Like
Okay.
on the fly name. It's not a variable name. That's what I like. I like to do on the fly things, not like give variable names. That's too risky. Okay, so we have the weights, we have the assignments. Now we just need to have the nodes. That's where that needs to have a cross product. Now it's not one-to-one, it's many-to-many. Basically, it's full cross product of all the nodes, right? That's where a little bit tricky. Well, we want those to have node 1 and node 2. I will show you a sublet. I mean, that's the best. So first, I know how to get that individually, but let's see that parallel. Oh, no, this will be echo. Let's think if we only have four nodes. But we want just a moment. Let's try only with 2 first because it might be too many. I'm doing this because I don't want 1, 2, and 2, 1. I only want 1, 2.
Yeah.
I don't want. I don't know if this will work, but. Okay, so if it's 2, it worked. 1, 2, 1, 3, 2, 3. I did some groundwork. I'm not doing it on the fly. I'm trying to get it integrated into that. I'm trying to do it on the fly. So this does seem I'll capture all the combinations, right? So yeah. Okay. So now the question I'm trying to do on the fly here is to integrate this into the how would I get all the, so what would I want is all of these combinations with the angles to have a cross product with this, right? The question is though, this filter, it's in itself. If it's not, then I would have. There are many ways, I think, but I want the most elegant way. Should I do it within? Should I do that? Should I do? Well, I guess I have to start somewhere because I am with. Also, let's see what happens if I do. One really silly way to do it is like I could do this to get node once. Yeah. Oh yeah, I know. So I could do this to get like node ones. I mean, there are like really awkward. I don't like this, but I think given time constraints, yeah, then I'll get all the first ones, then I can get the second ones. Well, oh, maybe you know what? Yeah, I got it. I'll bite the bullet and like call this like node one as an array. I think I can do it. Hopefully this will capture it as node one. Oh, I forgot to close one more. Yeah. So this should give me node ones, hopefully. Let's see. I don't like creating more arrays, but good. It's ugly, but for now it'll do. So this would be node one, and then if I do print two, this would be node two. You see why it's ugly, but that's okay. It's gonna. I'll call this. I'll put it in the naming section above. If you, this is my okay. This is good. This we want a cross product. So node one should be all nodes. Correct. No, node one. Like this would be all of the node ones, but then node one, node two should have one-to-one mapping. Wow. I don't know if this will be crazy, pushing the limits of my own understanding of parallel, but this is what would be nice. You see what I'm saying? So we want a one-to-one mapping between node one and node two, but a cross product between the rest. We could do a mini experiment where to see how this parallel phenomena works. So mapping exercise. So let's try. So what we want is we only need, let's see. So we want a one-to-one mapping and a cross product and a one-to-one mapping test. So let's do first one. Second one should be one-to-one mapping. Let's call it ABC. This one should be one-to-one mapping with ABC. Then we want a cross product with 1, 2, 3, which in turn should be 10, 20, 30. Let's say. You see what I mean? Like so, and then if you have 3, 4, so we want A, B, B, C, C. That should match, and then all of that should match with 1, 2, 3 as a cross product. Let's see. But then 1, 10, 2, 20, 3, 30 should match. We'll see. I don't know. And then I'll make it like K. Let's see how it worked. Hey, help me here. So 110 is matching, 220 is matching, 330 is matching. So that's good. There's no cross product there. But beautiful. This actually worked to my pleasant surprise, actually, didn't it? Because that's what we exactly want. So this is the tract. This is assignment, let's say. These are the nodes, right? Node 1, node 2. That should match. So good that one didn't pair with 20. We don't want one pairing with 20. Perfect. This actually worked. And then there's a whole cross product. You see, you have the AA having cross product with 1, 2, 3, BB having cross product with. Oh, nice. Love it, love it, love it. Thank you. Thank you for being patient.
No, thank you for walking
I
through
think
this.
we are almost there. We are almost there. So we have basically, it's pretty much set. We just need to condorize it, which I'll show you. We're pretty much set. If we had like 10,000 cores, all we need is just this. Literally, we can. The parallel will actually run on 10,000 cores, or 2,000 cores, whatever. You'll use all the threads, but let's not do that because I don't think Wiseman can take it. Like if you launch all the threads on Inca or anything. But literally, let's read it as English. If you see what I mean, this header is just saying that these lists have names. Just in case if you want to understand that, what I mean is this is like I can call it first, second, third, and then like if I say fourth, if I just mention like header, then I can refer to them either 1, 2, 3, 4, or I could just say first like this. Let's see what happens.
Okay.
Yeah, it gives you more like readability instead of 1, 2, 3, 4. I used to do 1, 2, 3, 4 a lot, but this is pedagogical, so I can name on the fly without actually assigning variable names. Anyway, so what we are doing here is connectome to tag all the tracks that we created as an array with 4, 15, 30. Assignments, that's this. Weights, that's this. And those are all one-to-one mapping. The plus actually makes sure that it's one-to-one. And the node 1, which we got here, this is still it should be 68.
Yeah, I was going to say that we need to, yep. Okay.
Yeah. So 1, 2, those are literally like the those combinations. I'm calling them as node 1, node 2. Okay, let's do a dry run. Dry run, so the dry run is, it's gonna list what it will do, but without doing it.
Okay.
So I'll show you. That way you'll know the commands you're setting up are actually the way you want them set up. So dry run is a nice way to kind of to see, okay, something is fishy. That's okay. These things happen. What did it say?
And right now the nodes are set up so that it won't consider the self connection, like the diagonal, basically, or will it still run that combination?
Yeah, because you see, this is why. Because I won't consider
one minus. Yeah, that's true. Got it. Got it.
1 less than 2. That's the one that's causing it. And then I'm just taking, which is why I'm not proud of this block. But for now, to save time, there should be an elegant way where I can do this in one shot. Like I don't need to do 2 shots. Like but for now, I'll obsess about it at a second take because I just have so many other things I need to get to.
I know. Yeah.
No worries, no worries. The reason it didn't work is we never really ran the other arrays. We never really initialized the other arrays. So let's start doing that. So tracks, I think shift enter, that worked. Assignments, let's call it assignments. I think we're calling them assignments. Let's do that. I think weights also, let's be generous and use the full.
Yeah.
Weights, that's set up. Oops. Weights is set up. Let's set up node 1, node 2, just in case you want to know, basically like node 1 would have like, I didn't run. Didn't run. Oh, that's because here I didn't update here. Sorry, I didn't update that part. Did you see that? Like, yeah.
Yeah.
Okay. Please, come on. Come on. Who is pounding Maldi? Gosh. No, it's not. It's not. It's only me and Jose. I think it's being. Why is this taking so long? Did I mess up some of the? No, SQL. Okay, finally. Eesh. This is why I talk about Wiseman infrastructure. IT infrastructure is okay. Okay, so this is all the node 2. This is all the node 1. That's why you see it goes up to 67. This goes up to 67, and node 2 goes up to 68. Yep. I mean, you could do sorts and all that. Do you want clean? Well, yeah. I mean, you could sort and all that, but I don't think we should do that. Like, no. Let's not sort because that could mess up. No, this is perfect actually. Oh, actually, we should do one more thing. Is so K enforces the order because parallel might not enforce the order. So because I'm repeating it, we have to enforce the order to match the echo. Like Yeah, so because otherwise, like
Okay.
node 1 could match with something else. So let's actually make sure that's a good point. Because parallel, because it runs in parallel, like there could be shifts in depending on the availability, but K enforces the output should match the order of the input. Otherwise, if you say parallel echo A, B, C, like it could print BCA depending on the thread.
Mm-hmm.
But if you enforce K, it's going to match the order of the input. The output is going to match the order of the input.
Okay.
Which we need to ensure here because I'm running parallel twice. If I had run it in one shot, then I don't need that. But because I'm running parallel twice and extracting the first element and extracting the second element, I need to make sure the order is right. Okay, so that's good. So now run this. Oh, look at that. Look at that. You see how it's like, it's not running it, it's showing you what it would do. So it's like, for
Yeah.
example, let's see.
Wow.
It's doing, so let's read it. We need to set up the path. I forgot. See, we need to, oops. We need to make sure where we are going to write this freaking
Oh, shoot. Yeah.
Will we have space, first of all?
That's another thing I was thinking about. So
Gosh.
right now, the largest files that we will get are gonna be like for each angle, the largest connection for most of them is like cerebellum to cerebellum for some reason. And some of those files are as big as 3 gigabytes. But then after that one edge, they are all, the bulk of them are in the megabyte range. So they're significantly smaller than
But then
that
we have
one
all the other
edge.
combinations, right?
I know, yeah. Let me see. I think right now we have 1 terabyte open in Mover.
Only 700, not 1 terabyte, only 700 gigabytes.
Oh, 90. Oh, well, less. Okay.
I mean, will you submit the job? Okay, here's the thing. Could you handle those things? I mean, once, because so this is a good thing. So let's create the Condor stuff and then I'll let you handle the space stuff. Is that okay?
Yeah.
Okay. Yeah, because I just don't, I need to switch soon.
Yeah, I totally get it.
Yeah, so let's at least set up the Condor files, okay? And then I will let you handle the space and where do you want to change. And if you have questions, feel free to ask. So
yeah, sounds good. And I can take care of also like maybe we can put like placeholders for the output directories and I can fill that in.
exactly. So I'm not gonna change any. Okay, good point. So what I will do is placeholder. I'll just say place, and you could and then two outputs, right? Then there's a place.
The weights.
Yeah, 2 outputs. Okay, so now let's just counterize it, and then I'll push through the GitHub, and then you take it from there. Sounds like a plan, right?
Yeah, sounds great.
So I have a setup. I will have to push some of the Condor stuff for you, but I'll push those. I've been meaning to do that anyway for the. So first, I have built this function, which is easy actually, Condor echo. So this is how I do it. So I'll show you what I mean. Screen is too small, but okay, that's okay. I'll set up all of these basically. So the executable is first I have to make sure because I'm gonna, so you use single quotes if you want shell type of environment within those things you'll learn over time. And there are the things you could do to make it more readable. So first, what we want to do is the executable is this, because we remember in Condor you need executable. This is how I break it up. I first write the command and then I break it up. Simply args is this. Args is all of this. Then you just need to come up with name IDs. So executable args are the first command that you break up. And then you need, so what do I need? Environment, I don't need to set up executable num CPUs. Let's actually, we don't need a whole lot. We could just say 4 or 2. We want more parallel runs, right? Not, yeah, we don't want like each job to have so many GPUs. We're not using M threads or anything. Then RAM, I think we can just say like 4 GB. I think it's like this or something. Yeah, I don't know. These things, yeah. And then initial there, this is where the Condor log files will be written, right? I'll say placeholder for Condor logs. Yeah, you will update that. Export. Yeah. Oh, there should be a job ID. The main thing didn't. Oh, yeah. Don't I have a job ID? Okay. Uh, sorry. Why is this like this? No. There should be a job ID. No. That's probably because of the. Yeah, that's because it's empty. I need to have a job ID, and then I think it would work. Okay, so like for example, if I do job equals temp and then do what do I call? Yeah. You see? Okay. I just need to set job. Okay, perfect.
Oh.
Yeah. Basically, what are the unique identifiers here, Monica? Basically we could just pick. The only unique thing is the angles and the node. So we can actually make one more so that we don't need to worry about. So let's make one more. Angles 4, 15, 30, 45, 90, right? And then I can then literally say the job ID, because angles will fix the tracks assignment weights. So I can call it angles, and then node 1 and node 2. That would be the unique job ID for all the jobs.
Yeah.
Because 5 times 68 times 67 divided by 2, that's the unique job ID basically.
Yeah.
And then I just say Condor echo. I want to write it to I just say Condor echo. Okay, that'll Condor echo. I just want to write it to place. Well, for now I'm just gonna write it to mine, but you can write it to wherever. Condor dot. I'll call it BPA. I like the BPA name. BPA.dat. Let's say give it a date or whatever. And then I'll show you how it looks. And then that's it. You see how simple it was? I mean, at least relatively, from going from a dry run of the command to the condorizing it. That's because there is some. I'll share the Condor echo functions and all that. Like that's not. Actually,
yeah, I had never done it like this. I'm very impressed. This is really a lot more, I think, elegant than the way I've been running a lot of things.
No worries. I've been doing this for a long time. It's not that I'm any special. It's just time is a powerful teacher. I mean, basically. Okay, let's just try it. I mean, let's see what happens. It's no harm done, because this is just playing with text. So I don't even need to do dry run. Only thing I do need to do is, because I'm in a shell, these arguments need to be exported, because right now, if I don't have a shell, then I don't need export. But because I need exports, that's okay. Okay, I'm going to run this. Unexpected. Did I? Why? One other thing I could do is like export node 1. Yeah, that would export. I think I can't export directly like that, so you would export. I could then literally, what I can do is I don't need to run again. I can then literally export because I need to export those names into the shell. The only difference is if I put a single quote like this, then I can't access it's its own shell. Like it's its own shell. So I need to export those arrays, basically these arrays that, actually, no. What am I thinking? I don't. It's outside the shell. Sorry. You don't need to export anything, actually, now that I'm thinking about it. Yeah, you don't need. Yeah, because this is outside the shell. You see, shell closes here. Shell is closing this quotation.
From there to.
Yeah, so these are all parameters. These are all external. So I can access. I was thinking the node 1 and node 2 would need to be accessed internally, but no, not really. Okay, let's run it. If I have to run multiple lines though, I need to select them and then shift enter. I'm not gonna write to a file yet. This is just to print on the screen. You'll see how nice. I'm gonna reduce the size a little bit so we have more screen space. But you will see. I'll clear the screen and click here, and then shift enter. You see how it's creating all of these jobs. Like basically, you see what's happening. Basically, it's creating for each angle, for each node. You have the submit file, that is a standard submit file. You have the executable, the number of CPUs, how much RAM you're asking, the Condor logs and the log file and the arguments. The arguments, basically for this executable, all of these are literally passed as an argument. You understand what's happening, right?
Yeah.
That's it, basically. I think there should be a space between 4 and GB, which means I just need to put like this, I think. Like this. That's a small thing. I don't know if we need a space or not, but you'll figure that out. I mean, I think you do. Well, yeah, I think you do. But let's Control C. Let's try one more time just to make sure the quotations are all there. Yeah, so 4 GB. And if I do this, for example, then I can run the whole thing. It'll create, let's write it, right? Let's write this DAG out. Oh, actually, there's a nice feature. You might be wondering what's happening. You could just put like a bar. It'll show you progress bar. Hopefully, yeah, it'll show because it's doing some calculation. You see, it'll show you how much it'll take like 8 minutes. Yeah. Oh my gosh. Oh, it'll do some estimation. So these are all the combinations. Oh, why are there 55? Why are there 55,000? Shouldn't it be only oh, I know why it happened. Oh gosh, it should be 11,000. You know what did I miss?
Yeah, 11,003.
I missed the plus. Did you see what happened? I missed the plus. So that's why it went to 55,000 because the angles need to have a 1-to-1. Otherwise, it's doing all. That's why it's 55,000. It went from 11,000 to 55. I was like wondering why the heck is it 55,000? Because I missed the 1-to-1 mapping between angles and this. Huh.
Got it. Okay. Yeah.
See, now it's 11,000. I'm like, what the heck? See, that's why it's important to pay attention. That's why these numbers and these things are helpful.
And then just to make sure, because, yeah, this is excellent, but it's a lot. I need to review this code to make sure I have.
Of course, we have the
understanding every detail, but so this will write the submit files?
No.
But then
no, you only do this. Condor submit tag.
Oh.
That's it.
So it is writing all of these specifications for the job into the DAG file, and then I'll just run the DAG file, and that's what's going to run everything.
This is all you need,
okay.
basically.
Got it. I see. So then in terms of paths, I would just change. I mean, there you have Scratch, your last name, and so I would just change that to where I want it to be.
Wherever you want to write.
Okay, yeah. Got it.
To do, I'll just mention, to do is space calculations, output paths, output DAG to your location, and then submit DAG.
Perfect.
Does that make sense? Yep. And then, yeah, you can review this. Like, this is how the DAG looks. I mean, which we saw on the screen before.
Yeah.
Basically, like, yeah, these are all the jobs. It'll use the local submit.
Got it. Okay.
Yeah, I will push these. Well, we could do it together, I guess. I don't know where I saved this. Usually, I want to push this to public places. So let's see. There's no PHI in this, right?
No.
There's no PHI. These are just variable names.
Yeah.
So let's just do that also. So you're not wondering about. Sorry. No, what am I doing? What did we call it? So that's one you need. Oh, I already have Condor utilities here. Forgot. That's the one. You just see, I already have. I forgot. Like, so the Condor utilities, the Condor echo will come from this. That's it. This is the library. And if you're interested, that's already on the repository. I forgot that I had that. So great. So see, this is all I made. It's not even, this is the Condor echo function that I was calling. You saw that, right? Literally just this. Not complicated. I'm just echoing stuff. And then just two, I have two echoes, one for local Condor and for non-local Condor. That's it. Just it's not a heavy library. And then the submit files are basically the standard submit files. This is the one you are used to, I think. Basically, you have the universe, you have the environment, which I'm passing through as variables. I'm passing executable as variables, number of CPUs, which is what we set outside. Should transfer files. No, whereas for the non-local Condor submit, there will be stuff here. You can take a look. It's already there. I'm glad it's there. I thought I would have to push those. I pushed those long time ago, I think. Okay, so git status, git add, git commit. Yeah, gosh. You have a divergent and need to space out reconcile. You can do so by running one of the following. Oh, merge. I don't know why. Yeah, I don't know. I hope I'm not screwing it up, but let's see. This false, right? So that'll merge, right? I don't know. I'm just thinking.
I have no clue.
Don't worry. Yeah, it has to do with like these files moving around. Should I figure something out? Oh, I see. Well, can you check if you have access to this? I think you should. Go to my GitHub and like miscutils.
Where do you have an address to your GitHub or?
Oh yeah. Sorry.
Okay, I really haven't. I'm not really.
Can you share screen?
I don't know much about GitHub. I haven't used it that much. It's a big goal I have to learn more about it. But
why don't you share screen?
Yeah, I can share. So I here.
Okay, scroll up. So there should be a BPA connectome. You see, like biological plausibility analysis 1 minute ago.
Yep.
Like click that. That's the one we wrote together, like basically.
Okay.
Got it? And then the Condor utilities are in the subfolder on the left. If you look at, yeah, you need to like source. You need to source that function. You need to source the Condor functions for you to have access to the Condor echo. Does that make sense?
Yeah.
And download these Condor local submit. And I think you do need to actually click Condor functions. Click Condor functions. You might actually have to change the function. Scroll down. Oh yeah. You see how the echoes are line 19?
Yeah.
So that like you need to have absolute path to that. Like update it so that echo submit equals path to Condor utilities and Condor local submit, because you see what I'm saying. You understand?
So
Uh,
like I'll
hold on.
download it
Yes, you have to download it to your home folder or whatever.
and then
Update this
update the
to
file
the
here,
full
the
path
path
name,
here.
full absolute path name,
Got
because
it. Okay.
no matter where you run from, the submit files are accessible. Because I'll actually do one thing. I think what would help for you is to have an example of that. The I'm just gonna put it in the move R01, the DAG file, so that you can actually refer. I should have written it there to begin with, but I also want you to check that so that you know what. So go to study move R01 folder, like go to just move study move R01. Date modified, I don't know, look for BPA or name. I just put the DAG file in here. Can you refresh this or something? What? It's not there?
Sometimes it takes a second for it to like.
Oh, okay. But I put the DAG file. I put the DAG
Okay.
file, so you can take a look. That's just so. I mean, if you have questions, like I'm not saying, I think you're so good at these things. Like I think you are at a great place. But if you have questions, don't hesitate. I think you got it right. I mean,
Sounds
ideally, it would
good.
be nice if you submit the DAG today. That way, the weekend it'll
Yeah.
keep churning, and then we can update Brittany to whatever. That's why we're doing this, right?
Oh, here it is.
Okay, yeah. Open that
It
as a
just
text
showed
file.
up.
Yeah, just open it as a text file if you can. Like it's a big text file, but yeah, this will show you like what you should expect. That you see the first line, it's actually pointing to my Condor local submit. So wherever you have your submit, it has to point to your absolute path. That's what I'm trying to say.
Got it. Okay. Yeah.
Mhm.
Okay. This has been really helpful. I definitely, I want to review the code because I definitely get it,
Of
but there are
course,
things that are very new to
of course.
me. So, but
No
I'm
worries. Yeah,
also like, wow, very impressed because I hope I can learn some of these tips and tricks to like use it for other things too, because this is really, this
absolutely.
is great.